Today's video is going to be about writing equations from parallel lines. This is lesson 32. I just want to remind you to make sure you're filling in your guided notes. Sadly, today I'm not joined by my co-partner as he is preoccupied with other things, but I'll get us to where we need to be, so make sure you are following along as we go through these examples. Because we're talking about parallel lines, the first thing we need to do here is just identify and define what parallel lines are. That way we can use the definition to accurately solve problems that involve parallel lines. So here is a graph of two lines, line A and line B, and they are parallel lines. And we're going to use this image to come up with a definition for parallel lines. So if I was to write an equation in slope-intercept form for both of these lines, the slope for line A would be rise over run, and it's rising 4 and it's running 2. And the reason why it's 4 is because the increments that they're using for these axes is 2. So from 2 to 6 is a rise of 4, and then from -2 to 0 is a run of 2. And if I do the same exact thing for line B, find the slope, the rise here from -4 to 0 is again 4, and the change from 0 on the x to 2 on the x is 2. So we can say that the slope for line A is 4 over 2, which is just 2. And we can also say that the slope for line B is 4 over 2, which is just 2. Well, the y-intercepts for line A, let me erase this so that we can see it clearly, or the B value, is the point that this line is crossing the y-axis, and it looks like the y value that it's crossing at is 6. So we know that for line A, the y-intercept is 6. And then for line B, it looks like it's crossing when y is -4. So we know that b equals -4. So if I put this all together, here's my equation for line A. We have y equals, the slope is 2 times x, and the y-intercept is a positive 6, so we write plus 6. And then the equation for b is y equals, again the slope is 2 times x, and the y-intercept here is a -4, so we're going to write -4. So here are the two equations, and then here are the lines of these two equations, and it's fairly obvious now that the two equations have one thing in common and one thing that is different. And the thing that they have in common is they both have the same slope or rate of change. They're both changing at the same rate. And the thing that they have that is different is the y-intercept. The y-intercept for line A is 6, and the slope or the y-intercept for line B is -4. So let's go ahead now and just define what parallel lines are. There are two lines that have the same, and again we said slope, or you can say rate, they're interchangeably, but a different y-intercept, or we can say constant. We're going to use y-intercept and slope because we're not talking about real-world problems here. We're just talking about math. And now because these two lines have the same slope, which is the most important part of the definition for parallel lines, they are never going to intersect. And this is an important word to understand when it comes to parallel lines. So intersect each other. So the big takeaway here is that when two lines have the same exact slope, they're never going to intersect each other. They're never going to cross each other. It's never going to be a point where line A and line B cross each other because they're parallel. So now that we understand what parallel lines are, let's go ahead and use this definition in solving these next three problems. As I go through these problems, I'm going to use the process that we've been using, which is to overview, to break down the problem, then we're going to execute a plan, and we're going to close out. And the overviewing the problem is the most important part, because if you don't understand what the problem is about and you don't understand what it's asking for, there's no way you're going to come up with an adequate solution. If you don't believe me, really just look at any of the decisions our government has made in the last 100 years, and you'll see that there's a lot of politicians that do not solve problems correctly because they don't understand what the problem is even about. So let's avoid those mistakes by reading thoroughly and identifying what it's about and what it's asking for. Write the slope-intercept form of an equation of a line that passes through the point -3, -4, and is parallel to the line y equals 3x plus 2. So what is the problem about? It's about math, obviously, but it's about writing an equation for a line. So we're writing an equation for a line, and it gives us that right here. And what is it asking for? It's asking us for us to create or write that equation. So we're going to write the equation of a line. So now we know what it's about and we know what it's asking us for. We've got to figure out what they break it down. So we need the model that we're going to use to write this equation, and it tells us that the model it wants the equation in is slope-intercept form. And we know what slope-intercept form is. We know that the model is y equals mx plus b. And then we should identify what these key numbers are. So if we look at the numbers, the first numbers that it gives us is this coordinate point. Whoops. It gives us this coordinate point. Why is it doing that? -3, -4. And what does it tell us about this coordinate point? -3, -4. It says that the line that we're going to create an equation for passes through it. So this coordinate point is on the line, or is a solution to the line or equation that we're going to create. And then it tells us that the line we're creating is parallel to this line right here. So let's go ahead and input the information that we know about the model. What do we know? Well, we don't need to know what y is and we don't need to know what x is. What we need to know is what m and b are, and we know what m is, right? Because we know that if the line that we're creating an equation for is parallel to this line, and this line has a slope of 3, then we know that the line that we're creating an equation for also has a slope of 3. So we know that our line has a slope of 3. Well, does it tell us what our y-intercept is? Because that's the other part of this model that we need. And it doesn't say anything about where the line crosses, and the coordinate point that it gives us does not have 0 for x, so it doesn't give us the y-intercept. So we're going to have to actually find what b is. And how can we find what b is? So we're starting to transition into the third part, which is to execute the plan. Well, if you remember back to when we did tables, and we were given a table with a bunch of coordinate points, and we found the slope, and then it didn't give us the y-intercept, what we did was we took a coordinate point, and we plugged it in for x and y, and then we solved for b. Well, here's our coordinate point, and we've got our slope. So let's use that same exact process in finding our y-intercept for this problem. So our coordinate point here, where x is -3 and y is -4, since it's a solution to our line, we can go ahead and put in -4 for x, or y, sorry. For our slope, we know that it is 3. And for x, we know that it is -3. And I'm going to put a dot for multiplication. That way, I don't forget that these two things are being multiplied. And then we're solving for b. So when we're solving this type of equation specifically, the first step we're going to do is we're going to simplify. And we can simplify the right side because we know what 3 times -3 is. It's -9 plus b. And now the second part is just to solve using inverse operations, which we know how to do. We got to eliminate the -9 by adding a 9 to both sides. And we can combine these to 5. And what's left here, since these go to 0, is just b. So we've figured out what b is, or our y-intercept is. It's 5. So I'm going to go just write this up here so I don't forget it. And now the fourth part is just to close it out. So we've got all the information we need. Now we just need to type it in correctly. So y equals, our slope is 3 times x plus 5 is our y-intercept. And we're good. So let's move on to example number 2. And now, because we understand the process, we can move a little bit quicker through this example. Again, the problem is asking us to create a equation for a line that has this point, 1, -5 on it, and is parallel to this line right here. So if we're creating an equation in slope-intercept form, we need to figure out what our slope is, and what the y-intercept is. Well, we know what the slope is because we know that if the line that we're creating an equation for is parallel to this line right here, which the line that they give us is negative 5x plus 3, that the slope for this line is going to be the exact slope for the line that we're creating an equation for, because if they're parallel, they have the same slope. Alright, so we know that the slope for our line is negative 5. And then for the y-intercept, it doesn't tell us what it is, but it gives us a coordinate point on the line. And so what we can do is we can solve for b if we replace y and x with something. Then we can figure out exactly what b is. So let's replace y with negative 5 and x with 1. So now let's put all the information we have into our line. We know that negative 5 equals the slope, which is negative 5. Whoops, that's a weird number right there. And x is 1, and we know that they're being multiplied, plus b. So we're going to simplify, then we're going to solve. So negative 5 times 1 can be simplified to just negative 5. And now, since there's nothing we can simplify, we can just go ahead and solve. So we got to eliminate negative 5 by adding 5 to both sides. And then when we combine our like terms here, negative 5 plus 5 is 0. And we know that negative 5 plus 5 is 0 as well, but we don't need to write it. And we're left with b. So for the line that we are typing in, the y-intercept is 0. So that means that the line, and if I drew a coordinate point, the line is going to go perfectly through the origin, because that's when y is 0, right? So the question is, do I need to type in plus 0? Well, the answer is no. So when we type this in, we can just type y equals negative 5x. And we can leave it like that. If you put plus 0, you wouldn't be wrong, but I don't need to type anything more than I have to. So if I don't have to type it, then why would I? So we're going to leave it as y equals negative 5x. And if I wanted to make sure that this was correct, or this was the right equation, what I would do is I would take this coordinate point and I would plug it in for x and y to make sure that the equation comes back true. So if I put in negative 5 for y, and then I put in 1 for x, and I simplify it, I should get the number on both sides. Well, if I simplify this side, negative 5 times 1 is negative 5, and that equals negative 5. That is true. So we know that we created the correct equation. So let's go ahead and do example number 3. So again, we're creating an equation in slope-intercept form, and it tells us that the coordinate point on the line that we're creating an equation for is 3, negative 1. And it tells us that the line is parallel to y equals 1/3 x plus 2. So we know that since the two lines are parallel, they share the same slope. So we can write m equals 1/3 for our line. And then we got to figure out what b is, but we know how to do that now. All we do is take the coordinate point that is on the line we're creating for and plug it in for x and y. So x is 3 and y is negative 1. So y is negative 1. Our slope is 1/3. Don't let this fraction scare you. I know a lot of you guys are starting to tremble. X is 3, and we don't know what b is as we're solving for. So before I simplify and solve, I'm going to turn this 3 into a fraction because it makes it easy to multiply. And we multiply fractions straight across, multiply the numerator together, multiply the denominator together. So let's simplify. 1 times 3 is 3, and the numerator 3 times 1 is 3. And we have plus b, bring down the equal sign, equals negative 1. And we can actually simplify again because we know that 3 divided by 3 is 1. So we have negative 1 equals 1 plus b. And now we can solve by subtracting 1, and then we get negative 1 minus 1 is negative 2. These go to 0, equals b. So we can go ahead now and type this in because we know that b is now negative 2. So when I type this in, I write y equals 1, and then we type in x in the numerator, so don't forget that, over 3 minus 2. And you could also type this in without the 1 in front of x, but both of them are acceptable formats. So good luck on the homework.